My name is Lee. I'm a teacher at St. Stithians College, and I'm very glad to be with you and to revise your grade 11 work a little bit before we move on to your grade 12 work. Right, today we're going to deal with functions, and what I'd like to tell you about functions is that they are probably the most important section of mathematics that you do, in the sense that they can count up to 40 marks in paper 1, and they come into just about every single section of mathematics. So let's talk about what functions are. Firstly, in grade 11, you would have learnt a whole series of them. The first one is the straight line, which of course you started as early as grade 9. And as you remember, the equation for this is y equals mx plus c. You might have also seen the equation ax plus by plus c equals 0, but that's just another form of the same equation. Right, so now if we're looking at the straight line, we know that there are several ways that we go about sketching it. The first way is the table method. And although there's nothing wrong with the table method, it is sometimes a bit of a long method to do and not very ideal. We also have what we call the dual intercept. Dual meaning two intercepts. And there we will be looking at the x and y. So if we looked at the x-intercept, we'd let y equal 0. And if we're looking at the y-intercept, we would let x equal 0. The last method we have for our straight line function is to work with, and by the way, straight line is also known as linear function. So let's put it up there. Linear meaning power 1. The last way we have to do it is to use the gradient intercept method. And of course, that is where the form y equals mx plus c becomes so useful. The c is always the y-intercept, and the m is the gradient. And how it works is if our gradient was overall a positive, so say it was that, the normal trend is to go up a units and across b units in that direction. And if it was a negative fraction, we would go down a units and this way b units. We will see it as we go, and as we work on the various things, you will see all these things revised for you. Right, the next function we learnt about last year is the quadratic function or the parabola. Quadratic meaning power 2. Better known as the parabola. Again, we have two formats of this. The one is y equals ax squared plus bx plus c. And the other format is y equals a x minus p all squared plus q. That is actually the better format to work with because this tells you a lot of what's going on in the graph. If you remember from last year, the a determines the shape. And how that works is if we have a positive graph, it is smiling, so it would turn that way. And if we have a negative graph, it would be sad, so its mouth would turn that way. It's quite a nice way to remember it. Right, so what does the q do? The q moves the graph up or down. Interestingly enough, that it moves in the same direction as its sign. So if this said plus 3, it would mean move up 3 units. And if it said minus 4, it would mean move down 4 units. Now, what about the remaining variable here? And that is my variable p. Well, for p, this is what we call our horizontal shift. And this moves in the opposite direction to its sign. So if your bracket read x minus 3 squared, etc., etc., then you would move 3 units to the right being the positive side. But if it read x plus 3, we would move 3 units in a negative direction or to the left. Okay, so that's just a quick refresher of that. Just a few more things on the parabola in case you may have forgotten it. We can find the axis of symmetry. Now remember, a parabola will always have a line that divides it into 2 equal parts. So if I folded this over onto that, it would exactly coincide. And we can find this equation using x equals minus b over 2a. We also have a turning point, which is calculated by taking this value we get and substituting it back into the original equation to find the y that goes with it. Right, so we will be doing a sample shortly, so I'm not going to get any further into that. Perhaps one more thing I can mention about this is the domain and range. Now, a domain is all possible x values, and a range is all possible y values. So when I'm talking about domain, I'm talking about x, and when I'm talking about range, I'm talking about y. A good way to remember it is that D comes before R in the alphabet, and X comes before Y in the alphabet as well. So it makes perfect sense. Right, now obviously if you look at this drawing, if I was doing the domain, do you agree with me that this graph would carry on going infinitely out? And so I could clearly see that my domain would be all X's. But the range would be limited by the turning point. In this case, the lowest value I could have would be this Y value, and then it would go up to infinity. But if the graph turned this way, then the highest value I'd have would be this Y value here, and it would go down to minus infinity. We will surely look at questions that involve domain and range later on, but I just thought it was a good time to mention it. Right, what else did we learn in grade 10 and 11? We learned about the hyperbola. Now the format for a hyperbola is y equals kx over x minus p plus q. If you want to, we could actually use an a rather. I think let's stick to a because then we're using the same symbol all the time for it. So let's use ax. Now again, the a, just like it did on here, determines shape. But here it's not as bad if a is positive. And by the way, we could also write this as a greater than naught. Then I would be saying that we're talking about the first and the third quadrant. Now that will make sense when we sketch one a little later on. And then if a is negative, we are talking about a less than naught. And then I would be talking about this quadrant and this quadrant. Right, so what are the other things doing? So we said a does affect shape. It also affects which quadrant we're in this case. And now the q is exactly like the parabola. The q value moves the graph up or down. And this p value is exactly like the parabola as well. It moves it left or right, using the same rules as we use for our parabola. So in other words, it goes the opposite direction to its sine. Just some important facts with a hyperbola, and that is that we have what we call asymptotes, spelt like this. Now basically what these lines are things that we are tending towards but never crossing. And if you remember back to your trig graphs, you saw asymptotes when you were drawing the tan function. But just to refresh your memory here, the asymptotes on this graph that I've just drawn over here would be, say, something along the lines of y equals, let's make it negative 2 over x. Then the asymptote would have been the x and the y-axis. In other words, we would never cross the x and the y-axis. But in a general form, the asymptotes are given by x equals p and y equals q. Now, of course, in this case, there is no p, so that's why we're getting x equals naught. And there is no q, so that's why we're getting y equals naught to get those two asymptotes. Now, we will deal with questions involving asymptotes a little later on. Right, what is our remaining graph? It's the exponential graph. And sorry, just before we move on, I want to actually just mention, if I asked you about the domain and range on this graph, the domain would be all possible x's, which would be everything except for where there's the asymptote. So you could say x an element of reals, but x not equal to 0. And likewise with range, it would be all y values except for the asymptote. So in this case, it would be y an element of reals, y not equal to 0. And I'll bring that in a little later on again. Right, the exponential function is y equals probably a, b to the x minus p plus q. Once again, the a would determine shape. Now, what do I mean by that? It would determine steepness, and it would also determine where we are. So if our a is greater than 0, our graph would be drawn spanning the first and the second quads, either there or there. But if a was less than 0, the graph would be drawn spanning the third and the fourth quad, because it would flip it down. But we'll talk about that some more when we get to our log section in Matric, where we again visit these graphs and work with them. Right, the q value again moves it up or down, and the p value moves it left or right. Okay, once again, there is an asymptote, and the asymptote happens where y is equal to q. So in other words, if I was putting it in on this drawing here, this would have been my asymptote. And if I had an equation, it would have probably been something along these lines. So that means there is no q value, which means the asymptote is the axis. But again, when we get to log graphs, we will spend a lot more time on these graphs. Right, let's now go and look at a typical graph interpretation question. Okay, you can see here it says in the diagram, the graph passes through the points A, B, and C. So I think there's just a little bit of misprint there, not too serious, we'll just knock it out. Passes through the points A, minus 1, 0, B, 0, 6, and D, 3, 0, with G the turning point of F. The graph passes through the points D. So now this is another graph, and I can see here's the graph of G. Passes through, so G being this graph here, and F being this graph here. And they're saying this graph passes through this and G. E is the y-intercept of G. So E is the y-intercept of G, it's here, and we'll worry about that shortly when we see what the questions are asking. So, right, let's concentrate on what they're asking us to do. They're asking us to show, firstly, that the equation of the parabola is given by that. Now, for some reason, people think it's okay to just go and substitute these points in to this equation. But if we're doing that, we're actually assuming that that equation is right. And we can't make that assumption. So what we have to do is we have to start working as if we never knew what it was going to be. So right, to do that, we have a situation where we are finding the equation of a parabola, and we are given the x-intercepts and one other point which happens to be the y-intercept. Now, if we're going to do that, the format we used last year was y equals a, x minus x1, x minus x2. Now, x1 would be this one, and x2 would be this one, or vice versa, it doesn't matter. But basically what it is the x-intercepts that we're going to input there. So I come along here and I say y is equal to a, and this is going to become x plus 1, because it's going to be x minus minus 1, and this one is going to be x minus 3. Now, at this stage, the only thing that we need to still find is our a value, and that is where our extra point comes in extremely handy. So what we're going to do now is we're going to substitute the coordinate 0, 6. So in other words, wherever there's an x, I'm going to put a 0, and wherever there's a y, I'm going to put a 6. So I'm going to get 6 is equal to a, and this is going to be 0 plus 1, 0 minus 3. So we have 6 equals a, and that's going to be 1 times minus 3. So we have 6 equals minus 3a, which means a, if you divide both sides by minus 3, is equal to minus 2. So what do we have? We have y equals minus 2, x plus 1, x minus 3. And now what we're going to do, because we have to show it in a particular form, if you look down to the question, they want me to show it looks like that. So as it stands at the moment, I can't say for sure that that's the same thing. So what I need to do is multiply that out and collect like terms. So minus 2, and this here is again foiling. So the first time together is going to be x squared. The outers are going to be minus 3x. The inners are going to be plus 1x. And the lasts are going to be minus 3. That means I have minus 2 times x squared, and of course these are like terms, so it's minus 2x minus 3. And if I distribute the negative in, I get minus 2x squared plus 4x plus 6. And that is exactly what I had to show, and so I've actually completed my first question. So notice I at no stage used this expression. I worked from what I had on my drawing to actually prove it. It is not sufficient, and I repeat that again, to go and substitute the points in and say the 3 points satisfy the equation, therefore that's the equation. It's not acceptable as a show or a proof. Right, so now we're happy that we've established that. Let's just clear my drawing up a little bit so it's a bit neater to look at. I'll leave that one over there for a little bit in case you are making notes. And let's go down to the next question. The next question says, determine the coordinates of G, the turning point of F. Now, of course, why have they given you this equation? They've given it to you so that if you can't actually solve it yourself, you can still carry on with the rest of the question. Now, this is very important exam techniques, because if you don't do that and you just stop doing the question, you'll lose all the marks that follow. So now, even if you had not managed to do that yourself, you could safely move on to the next question, which is to find that turning point. Now, earlier on I mentioned that we could find the axis of symmetry of this graph, which is actually the x value of that turning point, by using the formula x equals minus b over 2a. So let's go down a little lower on the page and let's work with it. We've got the equation up there, so there's no problem. And we know that y is equal to minus 2x squared plus 4x plus 6. So now, for the axis of symmetry, we are going to use x equals minus b over 2a. Now, if you remember, this is a x squared plus bx plus c. So what we're going to do is we're going to say first of all, x is equal to. Now, if I look at this, the a is equal to minus 2, the b is equal to 4, and the c is equal to 6. So if I'm going to use this formula I've just got, it's going to be minus the b, which is minus 4, 2 times my a, which is minus 2, which is minus 4 over minus 4, which is equal to 1. So that gives me x equals 1. So what I do know is that my turning point right now has 1 for x, and we still have to go and find the y that goes with that x. Right, to do that, what we do is we literally just go back to this equation, and we substitute in x equals 1. Because we know the x value, the only way we're going to find the y is to put it back into the equation. So y is equal to minus 2 times 1 squared plus 4 times 1 plus 6. So y is equal to minus 2 plus 4 plus 6. And if we work that out, it's going to be 8. So the coordinate is 1, 8. Now remember, if they've asked you in a test to give the coordinates of G, then you must write your answer as a coordinate. And so G is 1, 8. That's very clear to them now what's going on. Also remember that it's a good idea to fill in on the drawing as you find the various things, because that way you can have recall of what was going on. So let's go back up there to the drawing, and let's fill in the coordinate 1, 8. Right, you never know if that will be useful later on, so it's worth having it there. I'm just going to remove this now because we've basically done that. Right, so going back to the questions then, the next question says to me, if OC is half a unit, find the distance PQ. Now, at this stage, I want to stop for a few minutes and talk about distance. Now, what is very important here is that you remember that horizontals are x values and verticals is y value. That's worth remembering in every aspect of mathematics. So when I look at this drawing and I say to you OC is half a unit, that is a horizontal distance, which means this distance here is a half, and in actual fact x equals a half because it's horizontal. Now what are they asking me to do? They're asking me to find PQ. So let's go back to the drawing again and let's highlight what we're trying to find. Now, at this moment, I'm in a very good position to actually calculate QC, because QC is the y value of the parabola when x is a half. So a sensible way to go is to start there immediately. So I could go to that immediately and I could say, right, I know that the equation was y equals minus 2x squared plus 4x plus 6. And I know that x is a half because they told me the horizontal distance was a half, so x is a half. And I can go over here and say y is equal to minus 2 times a half squared plus 4 times a half plus 6. Which if I tidy up is minus 2, and remember we always square before we multiply, so it's 1/4 plus, and if I'm doing this one, I could say 2 goes once and into there twice, so it's plus 2 plus 6. And of course I can now cancel that down, so I'm going to get minus a half, and if I add those I'm going to get plus 8, which means I'm going to get 7.5. So I'm saying to you that this distance here is 7.5. Now, in order to find my green distance, I need to find CP. Now, P is not on the parabola. P is on the straight line. But the problem is we don't have our equation of our straight line. So the first thing we're going to have to do is find the equation of that straight line. Now, remember, to find the equation of a straight line, we need at least 2 points or 1 point and the gradient. Now, we definitely don't know the gradient. And we do know that G is a point it goes through, which we know is 1/8, and D is another point that we go through, which is 3/0, which means I'm now in a position to find the equation using 2 points. So let's start first of all by finding the gradient of DE. Now remember our gradient formula is y2 minus y1 over x2 minus x1. Right, so looking at that, we would say to ourselves, right, we can use 8 minus 0 and 1 minus 3, which gives me 8 over minus 2, which gives me a gradient of minus 4. Now, is it possible that this has a gradient of minus 4? And what I would like you to do whenever you find an answer is just test for yourself whether this is a feasible answer. Well, if the gradient was negative, the line should slope downhill. Let's see if that's true. Well, yes, it is. There's the line that's going downhill. So that makes perfect sense. Right, so now we're ready to find the equation of the line. And here we have a choice of 2 ways. We can use y equals mx plus c, or we can use y minus y1 equals gradient x minus x1. I think we'll do both just to make sure, but as I say, I generally prefer this proof, but let's see how we go. So y is equal to minus 4x plus c. And now what we're going to do is we're going to substitute a point in, and we've got 2 possible points. And I think I'm going to use the 3, 0 because it's a bit easier to work with than 1, 8. It really doesn't matter though. So I'm going to replace the y with 0, and I'm going to replace the x with 3. And doing that, I'm going to get 0 equals minus 12 plus c, and so c is equal to 12. So right, if that's the case, we've already established that, so that means the equation is y equals minus 4x plus 12. Now I'm just going to clear this and put this equation we've just found here, so we've got it for future reference. It's y equals minus 4x plus 12. Right, the other way of doing it is to go to this formula. Now this formula, we would use this as our x1 and our y1. So we go y minus 0 equals gradient, which was minus 4, x minus 3, which then gives me y equals minus 4x plus 12. As I say, that's just a little bit more elegant, and elegant is good in mathematics. We don't mind elegant work. So either way, we get the same equation, which was really what was important. Okay, now that still hasn't solved my problem. Now, I'm sure you can see by now that this would be considered a complex question because it's requiring you to tap into a whole lot of extra steps to be able to get to the final answer that you require. I mean, here you are, you're innocently going along. It was very easy to find that. Here, to get this distance, you've got major work ahead of you in that you've had to find the equation, and now only are you in a position to find the y distance, this distance here, for PC. So what do we know? We know that the x value is plus a half. So we're going to substitute that in. So y is equal to minus 4 times a half plus 12. That will go once, that will go twice. So we're going to get y is equal to minus 2 plus 12, which means y is 10. So what does that mean? That means that if I wanted to, I could loop this here and tell you that this distance here is 10. Now, if this purple distance or pink distance is 10 and this distance is 7.5, is it any problem to find PQ? The answer is clearly no, because if we've got the two y values, it would just be a matter of saying 10 minus 7.5. So we would say PQ is 10 minus 7.5, which means we're talking about 2.5. Now, sure, that was a lot of work, but these things are quite mark intensive. You could be talking anything from 6 to 8 marks for this question, probably more like 8 because you had to find the equation of the straight line yourself. Now, what is interesting about this is there's another way you could do it. Now, I'm always hesitant to show two ways, but I think it's quite good because some people relate to one way better than the other way. So it makes sense to me to do the second way. Now, the second way would involve finding the equation exactly like we did before, and so we would come up with this equation in exactly the same fashion. But now, what we would do is if I said to you, let's find the difference in our ages. I would take my age, subtract your age, because mine is the greater one. Now, if we're looking at this drawing, greater in terms of a sketch is the one that's highest on the page. So if I have a look there, P is definitely higher than Q. So if I was talking about PQ, I would say the y of P minus the y of Q, because just in terms of that being bigger than that. Okay, so if I'm going to do that, then what I would do is I would work wholly and solely with my equations. So I would go along here and I'd say PQ is. Now the y of P is actually the equation of the straight line. So I would say minus 4x plus 12. And from that I would subtract the y of the parabola, which is the equation of the parabola, which is minus 2x squared plus 4x plus 6. Now, once I'm here, I would tidy it up. So I would say minus 4x plus 12. Remember that negative there is like a -1, so we have to change all the signs. So we're going to put those signs through there. So minus times a minus is a plus 2x, and a minus times a plus is a minus, that's a square, 4x, and a minus times a plus is a minus 6. So adding up your like terms, then we're going to have 2x squared. Here we got minus 4x and minus 4x, so it's minus 8x, and 12 minus 6 is actually 6. So we know that PQ is given by that expression. Now that expression represents the distance between the two graphs at that point. Obviously, if I was down here, the parabola would have been higher than the straight line. So it just depends where we are. If we're here, parabola, subtract straight line. Here, straight line minus parabola. Now, what do we know? We know that x is a half. So we could go here and say PQ is equal to 2 times a half squared minus 8 times a half plus 6. Right, which gives me 2, and a half squared is a quarter. A half of 8 is 4 plus 6. And remember, don't be shy to use your calculators if it makes it easier for you to do the arithmetic. Right, so 2 times a quarter is a half, And minus 4 plus 6 is plus 2. And if you add that, you get 2.5, which is exactly the answer we got earlier on using the other method. So that's really a very nice question, and there are two nice ways in which you can do it. Okay, I see I missed out a question here, which was very bad of me, where I was told to find the values of m and k, and I made it part of that question, which is actually kind of them to have done that, because then you knew to find your straight line first, and then to go back to it. But it doesn't matter. You would have just found that out when you were working out your PQ anyhow. Right, let's move to the next question. The next question, as you can see, I have decided to work with a hyperbola, just so that you can have a bit of experience about how we put together the sketch of that graph. Now, again, I didn't mention the ways we have to do it. We can always use table method to sketch these things. But there's also a cleverer way, and that is to use the properties of this graph to decide it. So what is this negative telling me? Remember from the little summary I gave you, the negative is telling me that we're probably over here. What is this 1 telling me? It's telling me take that graph and shift it 1 unit up, which means it'll do this, which means this asymptote lifts off the axis to there. And then the last thing that this equation is telling me is this. And remember I said to you we move the opposite way to our sign. So it says minus 2. So we are going to move it plus 2. So we're going to take it over here. And so what's going to happen is we anticipate this kind of looking graph. Now it's quite good to have thought that through before actually putting pen to paper, because at least now I know that when I get to sketch it, I have a really good idea of how it must look. Right, so let's talk about sketching it. There's some important points that you have to do when you're sketching. As I say, you're welcome to use table method. But I think for the purposes of this lesson, let's have a look first of all at our asymptotes. So if I'm going to look at the asymptotes, do you remember how I told you how we find those? I said to you, we know that x is equal to p and y is equal to q. So if the format is a over x minus p plus q, do you agree with me that the y will equal 1 and the x will equal 2? In actual fact, what I'm doing is I'm literally putting this equal to 0 and solving for x. So now when I go to sketch it, and I think I'm going to use a dotted line so you can see the asymptotes clearly, we're going to sketch in y equals 1, like that, and we're going to put in x equals 2. Okay. Right, remember too that when you're doing sketches, it's very important that you label your axes clearly, x and y and the origin. And what is very important too with a sketch is you show them what's important. So you need to tell them that is a 2 and that is a 1. So they're clear how the graph works. Now the next thing I would do after that is I would find the x and y intercepts, because there will be x and y intercepts on this graph because it's shifted from the normal asymptotes of the x and y axis. So let's start with the x-intercept, which we get by letting y equal 0. So if I'm going to do y equals 0, I've got 0 equals, and in fact I might as well lift this page a little bit higher for now. Y equals 0, and I've got minus 2 over x minus 2 plus 1. Right, so now this becomes an exercise in solving fractions. So we're going to bring this across. And now you might have wondered why we made you do all those equations in grade 11. Well, this is just one of the many reasons why. So we bring this over, and we have it equal to 1. Now remember, we're trying to solve, so we need to times by LCM, which in this case is x minus 2, so it's going to become 2 equals 1 times x minus 2. And therefore, x minus 2 equals 2, which means x equals 4. So I know that at 4, I have an x-intercept. And it looks to me as if I might have to extend this line a little bit, because I haven't allowed myself enough room there to draw nicely. Okay, I'll just move that out a bit. Right. Now the other thing I'm going to do is I'm going to find my y-intercept. So my y-intercept I would get by letting x equal 0. Now that's an easier one than the previous one. So what I have y equals minus 2, 0 minus 2 plus 1. So y is equal to minus 2 over minus 2, which gives you plus 1, and so y is equal to 2. So I go over to my drawing and I put in the 2, and I'm ready to sketch. Now, in actual fact, I can just sketch freehand, because most of the most important things are there already. Let me just extend my asymptote. And here I also sketch freehand that drawing. And that's more than adequate as a sketch for the graph. So it's worth remembering it. You, of course, can use the table method as I explained. But doing the table method can be dicey, especially if you are moving the graph up and down, left and right. Because what values do you start at? What values do you end at? And you could have a problem. Our calculator, if I remember rightly, does have a table function. Let me just bring it up and just check on that. Yep, let's just clear that. You go to mode, you hit the table, and now you would key in that equation. So that equation is minus 2 over, and what was it again? It was x minus 2. So to get x, you go alpha x, and it's minus 2, is it? Yes, minus 2. And then you space bar out of it, and you go plus 1. You then hit equals, and it'll tell you where do you start. Now, if you have done your asymptotes already, you would know that 2 is sort of where the middle of the graph is. So if you went from minus 2 to, say, 6, you'd get quite a nice spread. Now it asks you what steps. Steps of 1 are always good. We press equals. Then what comes up here is a whole table of values. Now you see here, this one here, it's not very pretty to sketch, but that's better than sketching that one. So I would sketch that point. I would then go to the 0, 2, and as you go along, I choose all the nice numbers. The error means that there is an asymptote there, which of course if you look here is true. There's your asymptote. Right, there's another point that's quite reasonable, another one quite reasonable, and you can use those points to get the shape. So the graph can be done just using table method on your calculators. Right, let's go down to the next question. And the next question here just basically ties in with this one we've just done. It just says write down the equations. Now, if you've done it on your drawing, but you haven't written the equation down, that's not good enough, because the instruction was write down the equations. So if we do that, remember how I've shown you, this is y equals minus 2 over x minus 2 plus 1. So to get the 1, I would take x minus 2 equals 0, and so x is equal to 2. And what I would do to help my marker is I put a block, or I'd underline the answer or highlight the answer just so it's easy for them to find. And the other one is just y equals that q value, which is 1, and there it is. Right, so that brings us to the end of the second question. Let's now move on to the next question. And that is now one where it involves a parabola yet again. But you might notice this time that we're not dealing with the x-intercepts of the parabola, but rather the turning points. So if we have a look over here, we've got a turning point minus 1, and another point, 0, negative 4, which just happened to be my y-intercept. Now, in the first question, when we did the x-intercepts, we worked with the equation y equals a, x minus x1, x minus x2. This equation, we would have to work with our traditional, the a, x minus p squared plus q, where the turning point of the parabola is given by pq. So what I'm saying to you in effect is that is your p and that is your q. So we would go along and we'd say y is equal to a, x minus 1 all squared, and then we would minus 1 over here. So y is equal to a, x plus 1 all squared minus 1. Now you might notice, just like on the previous question, we have to still find our a value. And to find our a value, we find it exactly the same way as we found it in the first question, where we say, okay, fine, let's substitute another point in, and another point is the coordinate 0, negative 4. So we're going to replace x with 0 and y with negative 4. So minus 4 is equal to a, 0 plus 1 all squared minus 1. And so we have minus 4 is equal to a, that is going to give me 1 squared minus 1. So minus 4 plus 1 is equal to a. So a is equal to minus 3. That means our equation is y equals minus 3 x plus 1 all squared minus 1. And that would be perfectly all right unless they particularly asked you to write it in a particular form. So they might have said, find the graph of f, writing it in the form of y equals ax squared plus bx plus c. And then in that case, you would have had to times that all out before moving on. Right, so that was a little small question. Let's move to the next one. Right, this question says that if we have the graph f of x equals x squared, sketch the graph of each of the following below. So let us start, first of all, let's get ourselves a nice color, by drawing this graph itself. Now, if we look at this, we know that it's a parabola. Its turning point is at 0. And we know that at 1 we're going to get 1, and at minus 1 we're going to get 1. At 2 we're going to get 4, and at negative 2 we're going to get 4 if we just use simple substitution into a table. So all I'm doing is I'm looking at minus 2, minus 1, 0, 1, and 2. And I see I get 4, 1, 0, 1, 4, and I've plotted those points. Now let us draw this graph in, and then we'll start dealing with the actual question. Now I'm hoping that this works, so this is a bit of an experiment to see if I can move this around without having to redraw it each time. Now the first graph they're asking me about here is to find f of x plus 2. Now we know that f of x plus 2 means take this graph f of x, which is x squared, and shift it up 2 units. So that is how that particular graph will look. Now you can see this is relatively easy to think about it as taking this parcel f of x and shifting it up 2 units. Right, let's go back to the original now. And the next graph talks about f of x minus 2. So if we go over here, f of x minus 2, that's telling me to pull this graph down 2 units. So it would now look like that. And you can see they then ask for the original graph, which is already there, f of x, and you can see that's positioned there. So all that this did and this did is shift the graph up or down, depending whether it was a plus or a minus. Otherwise, the shape was the same. Right, so now we're going to have a look at what happens with the next one. So going back to the question, we're looking at f of x plus 3. Now remember we discussed that if we got a plus 3, we're moving the opposite way to the sign. So we are moving this in a negative direction 3 units. And so that is how this particular graph looks. So you could go again, we go back to the original. Because of the x plus 3, we move it 3 units to the left. And you can see your turning point's gone from 0, 0 to negative 3, 0. Right, now what will a minus f of x do? Well, what the minus f of x does is actually reflects the graph about the x-axis. So let's take it back to its original position. There it is. And let's have a look at it. We know that we're saying y equals f of x. So if I'm talking about minus f of x, I'm talking about minus y. So in actual fact, what I'm doing is I'm picking this graph up and I'm rotating it around and I'm putting it in this position over here. So that is the minus f of x graph over there. Very nicely positioned. Now, of course, this one says minus f of x plus 2. So it's still in this position, minus 2. So what we're going to do now is we're going to pick it up and we're going to pull it down 2 units. And so this graph over here is the position minus f of x minus 2. Now, we could go back and draw these each in, but I think the important thing here is to have seen it. So let's start again, run through it one more time, just to remind you how it works. So let's rotate it around first of all. Turn it around. Okay, that was the original f of x, and it was positioned. Oh my gosh, I just decided to move the whole axis. Let's just get the graph rather. It was positioned like that. Now, that was the f of x, which is this graph over here. And what I'm going to do is I'm actually going to highlight it in another color. So there it is in the green position. Okay, then what did I do? I wanted f of x plus 2, so I picked it up and I dragged it up 2 units. So there's its new position. And so this one over here is that new green one. And then I'm going to take this green one that I've just found. So let's just put another color on it. Okay, we're going to pick it up, bring it back into its normal position. And now it says minus 2, so we're going to drag it down there. So you can see there clearly, we can write on here the various equations. We can say this one was the f of x. The green one was f of x plus 2. And this purple one is f of x equals, so f of x minus 2. So it's shifted down 2 units. Right, so we've now catered for these 3 graphs. We talked about this one next, which basically involved us taking this graph, and I'm going to highlight it in this orange highlighter here. And it involved us taking this graph and shifting it 3 units this way. So over there, you can see that's shifted to the left 3 units, and that's that little orange dotted line. Now, the next thing we did is we worked with minus f of x. So let's just clear that out. And let's go back to the pink one. I'll put the pink one on top of the pink one, so hopefully it'll only pick up one of them. And I'm going to pick that up, and I'm going to rotate it around. And I'm going to drag it down to that position. There's the y equals minus f of x. And then the last one we want to do is this guy here, which is minus f of x minus 2. So let's pop a purple one on top of that one. And we're going to pick it up. Okay, it's decided not to be kind to me. But let's hope I can pick it up now. And I can move it to minus 2. So that means I'm going to move it down 2 units. And it does work. There you go. So now this then gives me the last of these graphs. This is y equals minus f of x minus 2. So it's quite a nice little exercise, getting to move around a bit and seeing how this graph relates. Let's look at a slightly different slant on this graph. And it's not that bad. What we're going to do here is I've given you this red graph as the original. And what I'm asking you to do is to identify for me, so what is happening in each of these, namely A, which is this one, let's make it pink. Then what's happening in B, which is this guy here. And what is happening in C, which is the green one. And lastly, what's happening in D, which is this black one. Now what's happening here is this time they've drawn it for you, and you have to actually show them how it's moving. So let's start with the pink one. If we're starting from this red one, y equals f of x, do you agree with me that this pink one must take the form of minus f of x? Because definitely that red one has rotated around. In fact, let's see if we can pick it up and fit it. I'm sure I can. It's rotated around. And, wrong, moving the wrong thing. Let's move the red line. It's moved over there. So right, let's see if we can figure out how that worked. Let's just take it back to its original position. Okay, so you can see here it is, and it's fitting on there. So now what's happened? If it had just been minus f of x, then, I want to just pick the red one up, it would have been there. But you can see that it's also shifted 1 unit to the right and 4 units up to get that position. So in actual fact, what I must have for this pink graph, if it's moved 1 to the right, it must have been like that. And then it's shifted up 4 units. So it would have been that. So this is now my graph A. Right, moving on to B, we can see that it also involves the negative f of x. So let's first of all start by saying that. So our B is going to involve minus f of x. But we can see that something else is also happening. So if we look at this red graph, let's pick it up and see what's happening. The red graph has moved 1 unit to the right and 2 units up. So 1 unit to the right means that that must have been -1, and 2 units up would have been that. So that brings me to the end of question B. Now let's see what's happening with C. Now C is the green graph here, and it too is also working on the negative f of x. So let's go across, and this time we are working with the green graph. So let me just get the right color pen, so just now we've got it. And I'm going to pick up the red graph and bring it back to the minus f of x form. Now I'm over here, and what's going to happen is this graph is going to move 2 units to the left and 1, 2, 3, 4 units upwards. So we can see that if we're looking at this, we're dealing with a minus again, but the x is now moving to the left 2 units, so it's going to be +2, and it's moving up 4, so it's +4, and that gives me graph C. Now the only one left to do is the graph D now, and that one is back to the original format. So let's take our red graph back into its normal form. Remember, it was y equals f of x. Oh dear, I keep doing this to this poor thing. I don't know when I'm going to remember not to do it. Bring it over here, and there it is. And now you can see that this D graph is a smiling graph, but it's not the same as the red one. So let's see how that moves. Well, what has happened is this red one has moved 1 unit across. It hasn't lifted up or down. So at this stage, all I need to do is say that D is my original f of x, but it's shifted 1 to the left, so it'll be +1, and there's no movement on the y. It's not going up or down, so there's my equation of D. And you can see that this is a relatively simple procedure, just the opposite way to the previous one. Right, now let's move across to the next question. And you'll see in this question, I've decided to work with our trig graphs. We have several ways of handling these. I'm going to show you how to use the calculator for it. If you have that calculator, it's one way to do it. And the other way is to just use our basic shape of the graph. So before we even start engaging with a question, let's just go down to the bottom here and just talk about each of these graphs. Right, let's start with the Sine X graph. Now, usually what we do when we sketch these graphs is we draw from -360 to +360. It is important when you look at your question that you realize how far they want you to take it. Now, these are waves. So you have a smooth-like motion to them. And of course, that also means that they have a periodicity, so they occur every so many degrees. Now, with sine curve, we know that in this case, what we call the amplitude is the number in front here. So this is the amplitude. In this case, it's 1. So I know this graph is only going to go as high as 1 and as low as -1. Then over here, this decides the periodicity. So there's no number in front of the x. So that means it's doing a normal wave for sine, which would be done in 360 degrees. Now, the one way to do it is to remember a basic table. And the basic table goes as follows. It talks about your zeros, your minimums, and your maximums. Now, your zeros for sine are at 0, 180, and 360. Your zeros. Your minimum is at 270, and your maximum's at 90. So when I go to sketch this, assuming that that's the 90, the 180, the 270, the 360, and that's my x-axis, I would know that I would have a 0 here, a 0 there, and a 0 there. I would then have a minimum, which is -1 there, and a maximum, which is +1 there. This gives me the basic frame of the graph. So as you can see as I go along here, that's how I'd get it. Of course, this is a wave, so this motion will continue. And so we know that it'll go down here, 0, 1, 0. And they would get the shape again. Now, if you had trouble remembering this table, your calculator would help you out. Let's bring it up here. We're still on our graph mode or table mode, if you want to use that. So if we wanted to, we could just go sine alpha x and close the bracket. And then we'd say, right, where do we want to start? Let's start at minus 360. And where do we want to end? We want to end at positive 360. But now your steps can't be 1. If your steps were 1, the graph would not be able to come up on this thing here because it would just be too much information you were requesting of the calculator. So what we would do is we would say the period of a sine curve is normally 360 degrees. 360 divided by 4 means that we are working with 90 degrees. So we put in 90 degrees, we then press equals, and up would come the values, which would actually mirror the shape I've given you here. Now, why 4? Well, if you look at the graph, it consists of a crest and a trough. The crest is equally spaced over that section, and the trough is equally spaced over that section. So that's why I would divide by 4. And if you look here, every time, every 90 degrees, something is happening on this graph. Now, if I start to introduce, and let's take another color for this, a number in front of the sign, that is not problematic, because basically what that would mean is that the maximum would now go to 2 and the minimum to minus 2, but everything else would remain the same. So all that would happen is, in effect, the graph stretches up and down to a new minimum and maximum, but it would keep the same kind of shape. Okay, that wasn't a very good attempt, but it's good enough to explain. Right, so what happens now if I change something else? Say I introduce y equals sine x plus 1. Well, that's not going to be problematic, because what I'm going to do there is I'm literally going to do that like previous question, where we say, right, what does that do? It shifts the values up 1. So where normally we would have got 0, we're now going to get 1. So it'll be a 1 there, a 1 there, and a 1 there. Where we normally would have got a maximum of 1, we're going to get a maximum of 2. Where we normally would have got minus 1, we're going to get a minimum of 0. And as you can see, this purple graph is just the black graph shifted up 1 unit. Of course, the real fun starts when we get to shifting left and right. So let's just get rid of this for now. Of course, we'll be going back to draw a proper graph now on the question as such. So now if I say to you y is equal to sine, let's say x minus 90. So just like the parabola and just like the hyperbola and just like all the other graphs, if I say minus 90, I'm going to shift it 90 degrees to the right. So these values here are all going to move 90 degrees to the right. So here's my 90, here's my 180, here's my 270, and here's my 360. So instead of 0, I'm going to plot 90. And instead of 180, I'm going to plot 270. The minimum at 270 is now at 360, and the maximum at 90 is now at 180. So if you look at it, this is the kind of shape that's forming. And you can see that this would mean it would have continued like that. And of course, those of you that remember your work from last year will remember that that is actually equivalent to the graph of y equals negative cos x. Of course, that makes sense because we're using our co-ratios to change sine to cos. But you don't have to know that at this stage. All I want you to understand at the moment is that this graph is moving just like all the others. And if you really wanted to, you're quite able to use the calculator to get your table and use that. Right, let's go back to the actual question. Let me just get hold of that. Take that all away. And let's go to the question. The question said, sketch the graphs of y equals 2 sine x and y equals cos 2x for the interval minus 180 to 90. Now, if they give you an interval, it is extremely important that you do just that. If you draw beyond the restrictions they've given you, you'll be penalized, which would not be nice. So let's go to this. They want us to sketch from minus 180 to plus 90. So what I do myself to avoid myself making the mistake is I only mark my axis up to those points. Then I'm not tempted to draw beyond it. And in fact, even to make sure that I don't do it, I'd be tempted to make my axis a little bit smaller, which it doesn't want to let me do. But anyhow, let's try one more time. Yes, it is letting me do it. See if it'll do it on this side. That way, the temptation to go beyond my restrictions has been taken away. Now they tell me to draw f of x, which is equal to 2 sine x. Now if you want to use the calculator, we can do that. We can go over here. Let's clear it. Let's put a 2 in front of that sine x. Let's say from minus 180 to plus 90. Now the question you've got to ask yourself now is, over here, is it only one wave I'm drawing? And the answer is yes, it is only one wave I'm drawing. So that means it's 360 divided by 4, so it'll be 90. So it's steps of 90, which is correct, and I press the equals. And up come my values, which I will then plot on my graph. Right, so I know that it's a 0 here and a 0 there, and I know that this will be a maximum. And if I've got that shape going, I know that this would have been a minimum. And so this graph would look like this. I'm drawing it in bits. So there we have it. So that's the graph of f. Right, now I would suggest that even in your exam paper, you use different colors to put your graphs in, because often they ask you questions about these graphs, and knowing that which one you're referring to by saying, okay, my F1 is the black one and the blue one is the G graph, it just helps you to be able to answer your questions more effectively. Right, so let's go. The other graph was g of x equals cos 2x. Now this is a good one because I didn't mention this one earlier. Basically, we're now working with a cos graph, but we notice that we now want to do 2 waves and not 1 wave. Now the amplitude for a cos graph is normally 360 degrees. But because it's 2 waves in 360, we're going to have an amplitude of 180 degrees, which means when I get to sketch this graph, if I'm using the calculator, I'm going to put in steps of 45 degrees. So let's pull the calculator up and show you what happens. Okay, let's just clear that. And so we want cos 2 alpha x, close the bracket. Where do I want to start? I want to start at minus 180. I want to end at 90. But my steps cannot be 90. Let's just do that just to prove the point to you so you can see what happens. If I do steps of 90, you can see that these values are not showing any of the zeros. You're not getting a single 0. So it's very hard then to know where your zeros are. You could use your common sense a little bit, but it's not really a good idea when you're in exam conditions. It's much better to just be safe rather than sorry. So we'd take that, we'd start there, we'd end there, but we would now take steps of 45. And now you can see that the table values you're getting are much nicer. They're going along 1, 0, -1, 0, 1, etc. So that's a much better deal. Now, if you don't have a calculator, you would have worked with that little table idea I had with the zeros, the maximums, and the minimums. Zeros for cos are normally at 90 and 270. The maximums are 0 and 360. And the minimum is going to be at 180. Now, because of this 2x, what we're going to do is we're going to go to this graph and we're going to divide everything by 2. So 45, 135, 0 will stay 0, 180, 90. And we would now go and sketch it using those values. Okay, so let's look at this. We're going to say at 45 degrees, we're going to get a 0. And at 135, which would have been there, so it looks like every 90 degrees, so I can go backwards on that. And then I have a maximum at 0, which will still be there. The next one will be at 180, but I'm not drawing it, so it's 180 apart, so I know there'll be another maximum there. And then I have a minimum at 90 degrees. Now, 90 degrees would be there, and then, of course, it would have to mirror this side here. So you can see that by drawing this, I would get this graph looking at me. By the way, I'm sure you noticed that I just treated this graph as a maximum of 1 and a minimum of -1 because the number in front of that is a 1. Right. Okay, so we've got our 2 graphs. There we have G. And now we're ready to actually engage with the questions. I'm just going to erase this table. I will come back and spend a bit of time with that in a moment. All right, so let's go back to the questions now. So we've sketched the graph. Normally in an exam paper, the sketch of your graph would be about anything from 6 to 8 marks. 6 marks probably realistically with this question, and we've been told that they will ask at most 2 shifts or 2 changes within a graph, and I'm going to spend some time on that in a little while. Right, now the first question says, for what values of x is f of x greater than 0? Now f of x was the black graph. Now in terms of our axis, we know that greater than 0 is here, equal to 0 is there, and less than 0 is there. So if I want to know when is f of x greater than 0, then I'm talking about this portion here, which has just decided to go into predictives, but it's fine, no problem. Okay, so I want that section of the graph. So to answer the question, f of x greater than 0, I would have to tell them what x's would result in that. Now if I look at it, the x's start from 0 and end at 90. But I only want greater than 0. I don't want greater than equal to. So I would say the element of round bracket 0 degrees to round bracket 90 degrees. Of course, you're very welcome to use this notation. Remember, if you use this notation, your little crocodile mouths, for lack of a better word, must face the same direction. The smaller number goes here, the larger number goes there. And that would be the answer for B. So, very easy. I look at the drawing. I remember that above the x-axis is greater than 0, on the x-axis is less than 0, and below the x-axis is, on the axis is equal to 0, and below the axis is less than 0. Right, I'm just going to tidy this up. I didn't expect it to make such a mess, and I want to use the graph to carry on. So I'm just going to put in a nice version of that. Let's just get rid of this little bit and tidy up with the black, just so that we can see nicely what's going on. Okay, so let's go to the next question, which says, B, for what values of x is f of x times g of x greater than 0? Now be very careful about this question. It is actually very easy once you see it, but it's always a bit difficult to start because you've got to understand that they're asking for a combination of the 2 y values times together. Now if you want 2 y values to be greater than 0, you must have a positive overall answer. To have a positive overall answer, we could have a positive times a positive or a negative times a negative. So going over here, if I've got f of x times g of x greater than 0, I would have a positive times a positive or a negative times a negative. And either way, the answer would end up positive or greater than 0. Right, so in terms of my graph, if I look at my graph, how am I going to make sense of that? Well, I'm going to make quite a mess of this graph at the moment, but it's absolutely fine. What I'm going to do is I'm going to go along here, and I'm going to talk about the fact that if I talk about f of x being positive, that means it's above the axis. So this is where f of x would be positive. F of x negative would be along here, because it's underneath the x-axis, so on the negative side of the y-axis. Now, on the other hand, if I now go to the G graph, it's positive here, negative along there, positive there, and negative there. Now, it gets quite messy, as you can see, if I do that on the graph, but it's not the end of the world if I do it. There is another way, which might be better. What you do is you put in a line, or you just use your ruler. That would be absolutely fine. And what you're going to do is you're going to slide this ruler over the drawing. What you know is that they have to have the same sign, so both positive or both negative, which means, in fact, that they'll both be above the axis or they will both be below the axis. So if I pick this up and I slide along here, I can see clearly that one is 0, and then it starts 1 is negative and 1 is positive. So all the way to that point, those values cannot count. However, if I carry on sliding from here all the way to here, they are both below the axis, which means it's a negative times a negative, which is a positive. Right, now carrying on my sliding, here the one is positive and the one is negative, which is a problem. Just try and straighten this line a bit, which has decided not to be nice. And over here, at this point, they both become positive again. Then, again, one's positive and one's negative. So right, in the light of that, let us highlight what is appropriate. Well, we decided not there because one was positive and one was negative, but here certainly would be true because both the blue and the black graph are below the axis. Now, here they are on opposite sides, and over here they are both positive. So I'd be talking about those areas. Now, again, it comes back to whether you'd like to represent this using interval notation or set builder notation. If we're doing interval, please notice I'm not including the 0. So I would start at, this value was minus 135. At minus 135 degrees, and I would go all the way to minus 45 degrees. Notice I'm using a round bracket, which means not including. Or it starts again at 0 degrees, and it goes all the way to 45 degrees, also not including. The other way is, of course, to use our crocodile mouths. So using that, we're starting at minus 135, and we're going all the way to 45, negative 45. Or, again, using my crocodile mouths, there's my x, there's the 0, and here's the 45 degrees. Okay, so that basically gives me the solution to that. I think this is a good time to give you a quick summary that will help you in future. So let's quickly put a summary together. I will, in fact, you know what? I think I'm going to actually wait for the summary. Let's finish the question, and then I'll give you a summary at the end for these kind of questions. Right, now it says in the next question, if the curve of G is moved 1 unit downwards, give the equation of the graph which is now represented by G. But we become experts at that. We know exactly how to do that because we were working with those other graphs early on, and we learned that to shift downwards, we subtract. And they want me to shift 1 unit down. So in other words, I'm going to take the equation of G. I'm just going to clear here so we've got a nice space. G being the blue graph. So I would take G of x, and because I wanted to shift down 1 unit, I'd go cos 2x minus 1. Okay, so that's easy enough to do, and that would be the answer for C. Right, the next question, D, says to me, if the curve of f is shifted to the left, give the equation of the graph which is now represented by f. And it should have said left by 45 degrees. So that's missing there, so if we can just put that in. So moving f 45 degrees, f is the black graph, I must now say f of x equals, and how do we move left or right? We introduce something here. So if we're going to move to the left, we're moving negatively, so we're going to go plus 45. Oops, that wasn't a very good move. Decided to just realign itself. Okay, so let's just fix that up nicely. So you've got a nice answer. So it's going to be x plus 45 degrees. Okay, so that basically then brings us to the end of the question, and I'm quickly going to give you a summary of these horrible little questions with f of x's and g of x's in them, because most pupils find that extremely confusing. So let's just rule off here, and let's call this section summary. Okay, if they say f of x greater than 0, as you saw, this means when does the graph go above the x-axis? If I talk about f of x less than 0, then I'm saying when is it below the x-axis? So in terms of a graph, if I just stuck any old curve in here, if I'm talking about this version, I'm talking about these sections. And if I'm talking about this section, I'm talking about those. Okay, so that makes it very clear for us. Right, the only last thing I want to do is talk of a combination of the two. So if they're talking about f of x times g of x greater than 0, that means that f and g must be above the x-axis or must be below the x-axis. So in other words, here they are in the same place. So if I did a little rough sketch quickly, let's just stick a curve in like this and one in like that sort of looking thing. Let's just make this another color so it's easier to see. And now I'm talking about where are they positive. It would be here because they're both above, here because they're both below, and that's it. Okay, last thing we need to do is talk about what, oh dear, wrong pen. Let's talk about this one here, where we talk about f of x times g of x smaller than 0. Now that means f and g are on the opposite sides of the x-axis. So in terms of a graph, let's put the one in black, and let's stick one in blue, like that. I would be saying opposite sides, so there they're the same side. Here they're opposite sides to there, then they're the same side, and then they're opposite sides there. So I'd be talking about those regions. Right, so now I think we've sort of come to the end of this, and I think you've got a very clear idea now of the work you covered last year. We will, of course, revisit graphs when we go to our matric work, and we deal with the cubic function, exponent graphs, and log graphs. Thank you very much for joining us today, and I hope you have a nice day and look forward to seeing you next time.